Hello. In this video, we're just going to take a real quick look at an introduction to some exponents. You may know exponents as powers. You're probably familiar with exponents, but we're going to talk specifically in this video about zero and negative exponents. So what happens if the exponent is zero or negative? Our essential question is, how can I rewrite and evaluate expressions with exponents that aren't positive? But as a quick warm-up, let's just get a reminder of what exponents are. If you see something like this, that is 2 to the power of 3 or 2 with the exponent of 3, that does not mean 2 times 3, right? This is 2 times 2 times 2. That power of 3 means there are 3 2's being multiplied together. 2 times 2 is 4, times 2 again would give you 8. So 2 to the third power is 8. 4 to the fourth means I'm going to take 4 4's and multiply them all together. 16 is a common mistake here. It is not 16. This ends up being 256. We go to the bottom left. Now here, right, we have 5 to the third and 3 to the fifth. So the regular size number, which is called the base, okay, and this is on the next slide as well. The base is the number that you are multiplying, and then the exponent is the number of times you are multiplying it. So base is 5, so this is 3 5's multiplied together. That would give you 125 versus 3 to the fifth is 5 3's all multiplied together. 1, 2, 3, 4, 5. What's that? 9, 81, 243. You can type these into a calculator as well. You do not need to know these mentally, but yeah, I just don't have a calculator available to me at this point in time. Okay, so exponents, you've worked with them, you've seen them before. What we want to talk about is what happens if the exponents aren't positive. And let's just start with the easy one. Let's start with an exponent of 0. If you have an exponent of 0, doesn't matter what the base number is. If the exponent is 0, that is going to equal 1. Okay. So you take negative 4.2 in any calculator, raise it to the 0 power, that is going to equal 1. Decimal, doesn't matter, still equal to 1. Well, what if it's negative 1 point? Doesn't matter, equals to 1. The exception to that rule is 0 to the 0, and that's because 0 to any power is 0, but if any number to the 0 power is 1, like which one of those wins out? This is one that we're not going to fight over this. There's a couple different ways of thinking here. We're just going to say that does not exist. Okay, so 0 to the 0 power does not exist. D&E. Okay, so if you see anything to the 0 power, even if it's a variable, right? Variable means we don't know what the number is, but it doesn't matter because any number to the 0 power is equal to 1. Okay, so if you see an expression like this, remember, this is an expression. It's not an equation because there's no equal sign. Why does this keep popping up? 15y to the 0. Now, it's important to realize that this is 15 multiplied by y to the 0. Okay? And it's important to kind of separate those in your brain because that 0 power is only applying to y, not to the 15. Okay? So this is 15, just the number 15, times y to the 0. But like we just saw, it doesn't matter what the base number is. If I'm raising to the 0 power, that quantity is going to be 1. So this is as good as saying 15 times 1. Now you might say to yourself, well, what if y is 0? We're going to assume that y is something other than 0. So that number to the 0 power is going to equal 1. 15 times 1 is 15. So I can simplify 15y to the 0. I can simplify that to just be 15. Okay? We have something similar here. This is an expression of multiple variables, negative 12x to the fifth, y to the second, z to the 0. I don't know what x is, so I can't do anything with x to the fifth power. I don't know what y is, so I can't do anything with y to the second. But I do know that as long as z is not 0, and again, we are assuming that z isn't 0, z to the 0 power is going to be 1. So if I wrote this out with my multiplication symbols in between, I'd have negative 12 times x to the fifth times y to the first times 1. But then I could see that negative 12 multiplied by positive 1 is just negative 12. So I would just have negative 12 x5 y2. So We are not solving anything today, okay? Solving is what you do if you have an equation with an equal sign and something on both sides. We are not solving because we do not have there's no equal sign. We are just simplifying this, so we are trying to write the expression as short as we can, okay? Now, when we are dealing with exponents, the base number is negative. You have to be careful when you're typing this into a calculator, whether it's your iPhone, whether it's your iPad, if you have a graphing calculator, it doesn't matter. -4 to the second power is going to give you -16 in any calculator. But if you put -4 in parentheses and then put the second power, this is going to give you +16. Okay? And the reason why is because here you are saying, I want the negative version of 4 squared. Okay? Really what's happening here is that you are saying -1 times 4 to the second power. And with PEMDAS, we know that exponents occur before multiplication. So what's happening is 4 to the second power is 16, so this becomes -1 times 16, or what's the negative version of 4 squared, so it would end up being -16. That is different than this one, because this saying -4 in parentheses to the second power is saying I want to take -4 and multiply with another -4. Right? Raising something to the second power means you multiply by itself. Well, -4 times -4 is +16. So that's why this gives us a different answer. Okay? So just be careful. If you see the number in parentheses, you cannot skip over those parentheses. They are so important, especially with exponents. You can get away with some of it if powers aren't involved, but the moment powers come into play, you got to use parentheses if the base is negative. Okay? So it's kind of the first half. What happens if the exponent's 0? It's easy. You just call it 1. Now, if the exponent is negative, okay, this does not just equal -25. This is not, let's do this, not equal just -25. Actually, what's going to happen, if you type 5 to the -2 into a calculator, you're going to get 0.04. And the reason you're going to get 0.04 is what a negative power does is it actually changes the base. Essentially moves the base from the top of a fraction to the bottom of a fraction. What I mean by that is 5 to the -2 power would be rewritten as 5 to the +2 power, but in the denominator. Okay, so that negative power is basically telling you, hey, take this number and put it in the denominator. Okay, so 5 to the -2, I would move the 5, the base 5, that stays the same to the denominator, but by moving that denominator down, I'm switching the exponent from -2 to +2. And now since there's nothing left in the top of my fraction, I just put a 1 there because I got to have something in the other side of the fraction. So 1 over 5 to the second, well, I know 5 to the second is 25. And then a 1 stays on top. So 1 over 25 is going to give me that 0.04. Now, we want to keep this a fraction, okay? So if you see 5 to the -2 power, you are expected to write it as 1/25th, okay? So the key thing that happens here with negative powers is the base goes from the numerator to the denominator, and then the power switches from negative to positive. Good morning, Miss Hager. Hello. I'm making a video for our class. No, do you want to join, talk about negative exponents? No. Are you sure? All right, sounds good. Positive. Yeah, I'll just need a couple minutes. All right, so then 4x to the -5, if we have something like this, again, it's worthwhile to note that this is 4 times x to the -5. So that negative power is only applying to the variable x, not to the number 4. Okay, so x to the -5th power, I can't have an answer with negative exponent. So I'm going to resolve this by moving the variable x from the numerator down to the denominator. Okay, so 4 is going to stay on top. On bottom, I can keep the 1 there if I want. I don't need it anymore because I only put the 1 there because there's nothing in the denominator. So I'm going to move the x down to the bottom, and that makes it to the positive 5th power. Okay. Now, I can't do anything else with x to the 5th because I don't know the value of x. So this is as simple as I can make this expression, is 4 divided by x to the 5th. Okay. So it's kind of a weird one because, again, all we are doing is simplifying. But part of the simplification process is you need to get rid of negative exponents. So if you see a negative exponent in an expression, we need to do something to get rid of it. In the first example, we moved the 5 to the bottom and then said 5 squared is 25. In the second example, we moved the variable x to the bottom and changed the negative 5 to positive 5, but I don't know the value of x, so I can't do anything more with that. Okay. Big thing is you are moving the base from top to bottom, or as we'll see in the next example, vice versa. Okay, so something like this: 3x to the second, y to the negative third, z to the negative sixth. Okay, I don't know the value of x, y, or z, so I can't plug in any numbers. But this variable has a negative power, so it's got to move, and this variable has a negative power. So basically what's going to happen is all I can do here is make them switch places. Okay, so what we have then is the 3x squared is going to stay the same. Okay, the z is going to go from the bottom, or from the denominator, up to the top, and it's going to now get the positive 6 power. Okay, so z to the negative 6 on bottom becomes z to the positive 6 on top. And then the same idea with y. Instead of y to the negative 3 on top, I'm going to do y to the positive 3 on bottom. There's nothing else I can do to simplify this because I don't know the values of x, y, or z. So this is my fully simplified expression here. Looks crazy, but right now our goal is just to get rid of negative powers. Same thing here. I have the variable x has the negative 4th power, but that's the only thing that has a negative power or negative exponent. So I'm going to move x bottom to top. So I've got 5x to the 4th over t to the 2nd. Nothing else can be done to simplify this, so we are finished with our portion of it. Okay. The final thing that we're going to do is, what if I do give you numbers? Like, what if I tell you the value of r, s, and t in an example like this? Well, first of all, I'm going to ignore this. I'm going to ignore this information, and we're going to clean this up first. So I'm going to get rid of the negative exponents in this problem first, and then we'll go back and plug in the values. So t to the negative 3 is going to move to the bottom. S to the negative 1 is going to move to the top, and they're going to get positive exponents. So here we have 3r to the 2nd, s to the 1st, over t to the 3rd. Okay, so now we have all positive powers. Now I'm ready to go ahead and plug in my values here. So r is 2. Now, anytime, please, anytime you are plugging in or evaluating, replacing variables with numbers, use parentheses. Okay? With exponents, we got to make sure we use parentheses, especially when it comes to those negative values. So r to the 2nd, and then we have s to the 1st over t, which was positive 4, to the 3rd. Okay. So now if we do a little PEMDAS, right, all the exponents have to like work their way out. Like we have to take care of the exponents before we can do any multiplying. So the 3 is still here. 2 to the 2nd power is 4. Negative 3 to the 1st power is still just negative 3. And 4 to the 3rd power isn't 12, it's actually 64. 64. Okay. Now that the exponents are gone, I don't really need the parentheses. I'm going to leave them up top. And then just multiply the top to simplify this. So 3 times 4 is 12, times negative 3 is negative 36. What is happening? Okay, that's weird. So negative 36 over 64. Then all I'm going to do is simplify this fraction 2 2 goes into both, but so does 4. If I divide both these by 4, remember, simplifying a fraction is just like, hey, if both numbers can be divided or simplified by the same factor, happen again, let's do this quick, divide by 4, divide by 4. This gives me negative 9 over 16. That can't be reduced anymore, so bam, there we go, negative 9/16. Okay, so first get rid of the negative exponents and then go ahead and use the values that we were given. Go ahead and try that with this problem, and then we will we'll wrap this up. Okay, so I have this r to the negative 3, so it's got to move up top. What's weird about this is even though it tells me that t is positive 4, right? We know t is positive 4. We know that anything to the 0 power from earlier, we know anything to the 0 power is going to equal 1. So what we end up with here is negative 2 t to the 0, t to the 0, s to the 2, and then also what? R to the 3rd. So I move r up to the top, change the negative 3rd power to the positive 3rd, and since nothing is left in the denominator, I can just put it over 1. Which is nice because then I don't have to worry about simplifying a fraction. This is going to end up being a whole number. So if I plug in my values now, negative 2, I don't know why I keep doing this, negative 2 times 4 to the 0, s is negative 3 to the 2nd, and r is 2 to the 3rd. Again, it's all over 1, but I don't need to write over 1. I have negative 2 times 1. Negative 3 to the 2nd power is 9. And 2 to the 3rd power is 8. So now I can just multiply all those numbers together. Negative 2 times 1 is negative 2 times 9, negative 18 times 8. Oh boy, mental math. Negative 144. If I get this wrong, I'm pretty sure I'm good there though. 18, 8, 864, yeah. So negative 144 is my value. Okay. So again, make sure you get rid of the negative exponents and then go ahead and plug in your values. So to summarize, how can I rewrite and evaluate expressions with exponents that aren't positive? Anything to the 0 is equal to 1. Anything to the 0 power is equal to 1. And negative exponents move, oh my gosh. Oh, come on, negative exponents move the base. Oh boy. All right, we're just gonna end it. Negative exponents move the base to the opposite side of the fraction. iPad's freaking out. Video's over.